Hello there. Welcome to the Professors DuBois channel. This is Corey and Victoria, and we are the Professors DuBois. Today we're going to be talking about reaction stoichiometry.
So that stoichiometry word comes up again, and it's a big, intimidating, hard to spell word that you see in chemistry, but we learned before that it's really just comparing like the relative amounts of something to something else. And we started out with the compound stoichiometry, where we could take a compound and look at the mole ratios within the compound. So got an example here. It's calcium chloride. I can say that 1 mole of calcium chloride is equal to 2 moles of chlorine, or 1 mole of calcium chloride is equal to 1 mole of calcium. This is stoichiometry. Now what we're going to do is we're going to take a balanced equation and we're going to use those coefficients. Those are telling us the mole relationships between the different materials in the chemical reaction or chemical equation.
Yeah, and it's really important to know that we use this when we're converting one material into another. You probably already said that. I'm emphasizing it. All right, so here's an example of using this mole-mole ratio in a problem. So how many moles of oxygen are consumed when 0.6 moles of hydrogen burns? Now this is a reaction, so we're not talking about atoms of oxygen and atoms of hydrogen. We're talking about oxygen gas and hydrogen gas, and the way that they exist are diatomic elements. So we have to write them in the reaction as diatomic elements. So we have our H2 here plus our O2, and it's making water. So we have to balance our equation first. So there's 2 H2s, that means there's 4 hydrogens, and we have 4 hydrogens with 2 waters over here, and our oxygens are balanced. So the first step in reaction stoichiometry is always to have a balanced equation.
Well, what about those parentheses there? We haven't seen that yet.
That's a good question. So the parentheses after the formula, so here's this is an L, so it's parentheses L, and that is designating the state of matter. So H2 little g means gas, O2 little g means gas, and then H2O is liquid. So these are pure substances, and this is designating the state. Which one was missed? Was solid. And you might also see if something's dissolved in some solvent, you might see an AQ, and that means it's aqueous if it's dissolved in water.
So what we have with this question, we have to write the equation.
Yep.
Balance it.
Yep.
And the states were included here. We wouldn't expect you to be able to predict the states.
Not yet.
And we have 0.60 moles of hydrogen. We're going to start with that, and we're going to use the balanced equation. That gives us our mole-mole relationship. So we have 1 mole of O2 for every 2 moles of hydrogen, and that's our factor.
So when there's not a coefficient, it's a 1. So this is where these numbers are coming. This 2 moles of hydrogen is coming from this coefficient. And this 1 mole of oxygen is coming from the missing coefficient. So we start with what we know that's not a factor. Sometimes we'd like to put this over 1, so we know that that mole of hydrogen is in the numerator, and then we have mole of hydrogen in the denominator, so they can cancel. This 1:2 ratio is from our balanced equation. Now we've converted from hydrogen, now we've turned that into oxygen. So we've gone from one species to another. And now we have the moles of oxygen, which is what this was asking for.
In this case, we just kind of went from one reactant to the other reactant, but we could also go to products as well, and you'll see plenty of examples.
Anything in the balanced equation, you can go from one to the other. So this is our mole island step. Remember when we did the compound stoichiometry and we were using the example we gave you was the calcium chloride? That was a mole-mole relationship, and we could go from the number of atoms of calcium to the number of atoms of chlorine. We're doing the same thing. We have a mole island piece, and that is converting from one thing to another using moles.
So our mole island just got a whole lot bigger because initially we were just going from grams to moles, or from a count, we were using Avogadro's number, we could go to moles. But now you'll notice in the center piece here, we have mole number 1, mole number 2. This is the mole-mole relationship from the balanced equation. So this is where we can go from moles of one thing to moles of another.
From the reaction.
So we're showing here, like, you might be given a mass in milligrams or kilograms. You might have to convert to grams. But once we get to grams of one thing, we can use the molar mass or the grams per mole to get the number of moles. Then we can use the balanced equation to go from moles of one thing to moles of something else. And from there we could go to grams, or we could go to number of atoms. We could use Avogadro's number that's not on this drawing. In this whole mole island thing, it's just a visual representation. It's like a road map to kind of help guide you along when you're trying to solve these problems.
And these bridges on and off, this grams per mole, you always have that because that is from the periodic table. That's your molar mass or your gram formula mass from your periodic table. So that is this number here, this number of grams per 1 mole. And then so you turn mass of one thing into mass of another. And then of course you could keep going and converting your metric units from there. All right, so let's get an example.
It's the same reaction. We've got this written out, and I always like to check if you see coefficients, it's probably balanced, but just double check. It's cheap insurance to make sure you have a balanced equation because it's so important. So we have to go to the mass of oxygen by burning hydrogen. What mass of oxygen is needed to produce 27? So we're going to start with our water. That's actually our product. We're going to start with the water, which we have the number of grams. So we can go from grams of that water to moles of water. And then we're on the island, the so-called island. So we've got the grams. We're using the molar mass of H2O from the periodic table to get to moles. And then the mole ratio between water and oxygen is there's 2 waters to 1 oxygen. So the 2 moles of water goes in the denominator, 1 mole of oxygen in the numerator. The moles of water cancel, and then we can use the molar mass of oxygen as O2 to get the number of grams.
Yeah, be careful. Oxygen, if you look up on the periodic table, is 15.999, and you need 2 of them because it's a molecule of oxygen, not just 1 atom of oxygen.
Yeah, just another watch out. A little practice goes a long ways.
Speaking of practice, here's some. You're going to start with writing a balanced equation from words. So be careful. So we have formation of ammonia. So this is one of the ones that you're going to want to know. I'll just tell you what it is. It's NH3. And be careful. Oh, shouldn't have told him. It's okay. From hydrogen, this is hydrogen gas. So you need to know what hydrogen gas exists at. I won't tell him. Nitrogen gas as well.
Yeah, just check your diatomic elements and make sure you get that correct.
Know those, and then you can go from there with your.
So the first question is just you're just on the island with the 2.9 moles of nitrogen, and you're just going to use the balanced equation to get moles of ammonia. But the second one's a little more tricky. You're starting with grams, so that'll be grams to moles, and then the mole-mole relationship, and then moles to grams. So these are they're tricky at first. They're challenging, but
you'll get them.
You'll get it. A little practice will go a long way.
We'll use this over and over and over and over and over again. So this you need to master this technique. All right, here's the pause if you didn't yet, because I'm going to show you the answers. There you go.
Right.
Answers in red. I'll let you take that down. And that concludes our video for reaction stoichiometry.
Right.
Yeah, so make sure you practice that, and we will catch you in the next installment.
Thanks for watching.
Bye-bye.